By how many newtons does the weight of a 100 kilogram person change when he goes from sea level to an altitude of 5 kilometers if we neglect the Earth's rotational effects? Okay, so to do this question, we need to know what the mass and the radius of the Earth are. So I'm just going to put that information in here. This is all going to be on your formula sheet. All right, so when the question asks how many newtons does the weight of a person change, the weight of a person is the same thing as the force of gravity acting on the person. So what's the formula for the force of gravity? So we have force of gravity is equal to, so we learned a formula earlier on in the course, which is Fg equals mg. Now that is only true if we are close to the surface of the Earth, where g would be 9.80 meters per second squared. Okay, but in this case, we don't necessarily know what the g is, since we're going from sea level to a certain altitude. So we want to figure out what the force of gravity is at various positions or heights from the surface of the Earth. Okay, so we're going to use the longer formula, which is force of gravity equals g, which is a gravitational constant, it's always the same value, times mass of the person. Okay, so I'll call this mass of the person, times mass of the Earth, which is this value here that would be given to us on a formula sheet, mass of the Earth, times the distance squared. Now this r is the distance between the center of each of the objects. So if we have the Earth over here, and the person is at sea level, that means that they're right at the surface of the Earth. And so the distance between the center of the person and the center of the Earth would just be the radius of the Earth. Okay, so that's the radius of the Earth, and we know that value right here, radius of the Earth. Okay, so now this, if we're using the formula at sea level, force of gravity, or the weight of the person at sea level, then this r would be the distance between the center of the Earth and sea level, which is where the person is, which would just be the radius of the Earth. Okay, but when we do the formula a second time, when the person is now 5 kilometers, is at an altitude of 5 kilometers, so now the person is over here. So the r value is the distance between the center of the person and the center of the Earth. So now that r value would equal the radius of the Earth plus 5 kilometers, or 5,000 meters. Okay, so I'm going to do the same formula on this side, force of gravity, but instead of from sea level, it's going to be at an altitude of 5 kilometers. Is equal to the same formula, the gravitational constant times the mass of the person times the mass of the Earth, divided by, now instead of just the radius of the Earth, it's the radius of the Earth plus 5,000 meters, all squared. Okay, so we can start to find out what the difference is here. The question wants to know by how many newtons does the weight change when he goes from sea level to an altitude of 5 kilometers. So what we're looking for, that difference in the force of gravity. Okay, how much does it change? How much does his weight change by? We're trying to find the difference, so it's from when he's at sea level to when he's at an altitude of 5 kilometers. So it would be the force of gravity at 5 kilometers minus the force of gravity at sea level. So I can start to put in my numbers here. Well, I'm going to put in the formulas first. So g, mass of the person, mass of the Earth, over the radius of the Earth plus 5,000 meters squared minus g, mass of the person, mass of the Earth, over the radius of just the Earth squared. Okay, so we can see here that there's a lot of things that are repeated in both of those terms, so I'm just going to factor them out. So I'm going to take out g, mass of the person, mass of the Earth, and I'm left with 1 over re plus 5,000 squared minus 1 over re squared. And that makes it a little bit easier for me to plug in my numbers. So g is a constant. It's the gravitational constant. It's going to be given to you on a formula sheet, 6.67 times 10 to the negative 11. The mass of the person is given. This person's 100 kilograms. The mass of the Earth is 5.97 times 10 to the 24 kilograms. And now we have 1 over the radius of the Earth, which is 6.37 times 10 to the 6 meters, plus 5,000 meters squared, minus 1 over just the radius of the Earth. All squared. So when I punch this into my calculator, I get negative 1.538, which gets rounded up to 1.54. This is a force, so it's in newtons. Okay, if I go back to my original question and I look for significant figures, I can see I have 4 significant figures here, 3 here, and in my question, I also know the constants, 5.97 and 6.37. So those have 3 significant figures. So the fewest number of significant figures that was given to me is 3, so my answer should also have 3. Okay, so if we just look at this question one more time, it asks by how many newtons does the weight change when he goes from sea level to an altitude of 5 kilometers. So we're going to find his weight, or the force of gravity acting on the person at the altitude of 5 kilometers minus the force of gravity acting on him at sea level. Okay, so I hope this makes sense, and thanks for watching.